Hello students, welcome to EPG Pathshala. Today we will learn about the wastelands. The chapter will include what are wastelands, what are different types of wastelands, what are their reason of formation, why we need the wasteland reclamation, then wasteland reclamation methods and wasteland Indian scenario. So, introducing with the subject, we all know land is the most precious resource on this planet earth and is the natural home of most of species of plants, animals, microbes, etc. The primary sources of food for the lives on land come from the plants growing naturally of specifically grown for the purpose. With advancement, humans and technology, domestication of plants in the form of agriculture started. The agricultural products now provide the raw material for most of the human needs. The land available on earth is not uniform and differs geologically, geographically, environmentally, climatically, etc. All the landforms do not naturally support vegetation or life due to climatic and edaphic conditions. And many landforms which were naturally productive have become unproductive due to various anthropogenic activities. These unproductive lands, whether due to natural or anthropogenic causes, are in general called wastelands. So, defining wastelands, what is a wasteland? The barren or degraded lands which do not fulfill their life sustaining potential are called wasteland. Some of the agricultural fields degraded or unfit for profitable cultivation are also often considered as wastelands. The most commonly used definition of wasteland is any type of land which because of neglect, overuse or degradation by climatic and or anthropogenic factors is not being used to its fullest potential has been regarded as wasteland. The National Wasteland Development Board, Government of India defines wasteland as land which is presently degraded and is laying unutilized except current fallow due to different constraints. Now, what are different types of wastelands? The wastelands can be mainly classified into two types and then subdivided into several types. These two types are cultivable wasteland and number 2 non-cultivable wasteland. So, defining cultural wasteland, these are the wastelands which can be cultured easily or without much difficulty. That is, no special measures are required for their reclamation. These may reclaim at their own naturally with time, whereas non-cultivable wasteland, these cannot be reclaimed easily and natural reclamation of these lands is not possible. These can be either reclaimed with extreme difficulty or cannot be reclaimed at all. For the types of cultivable wastelands, number 1 gullied or ravenous wasteland, then steep sloping area or undulating uplands, waterlogged or marshy lands, salt affected lands, degraded forest land, shifting cultivation area, degraded pastures or grazing lands, mining, industrial wasteland, land with or without scrub vegetation, degraded land under plantation crops. Then the types of non-cultivable wasteland, these are gullied or ravenous wasteland, barren rocky area, steep sloping area, snow covered or glacial areas, gullied or ravenous wasteland. This type of land is formed as a result of concentrated runoff flowing at very high speed. This runoff erodes soil and forms gullies. Fertility of these soils is very low and nearly zero level, as can be seen in the picture. Steep sloping area or undulating uplands. Lands having slope from 3 to 10 degree. These are unsuitable for cultivation due to high degree of slope which hinders in agriculture operations. These are characterized by accelerated water and wind erosion. The common vegetation present in is weeds, grasses, bush covers, etc. Waterlogged or marshy lands. These lands remain submerged in water practically for whole of the year. These lands may develop due to seepage of water from rivers, canals or waste reservoirs. These lands are formed near coastal and in other low-lying areas as can be seen in the picture. In next picture, we can see white color salt affected lands. These lands have deposition of salts on the upper layers of soil. The depth of layer depends on the quantity of salts deposited. The salts deposited may be soluble or exchangeable. When there is excess of soluble salts and pH above 8.5, soil is known as saline. When there is exchangeable sodium pH 8 to 10, soil is known as alkaline. These soils are usually fine textured, light with good porous space but low water holding capacity. Due to deposition of salts, color of upper crust vary from white to grayish white. Due to removal of forests for fuel and firewood, degraded forest lands are formed. The tree canopy has been reduced and trees almost look like bushes or merely skeleton and they are not able to further grow. The soil of this area is good for planting crops provided used with care. Shifting cultivation area. The land areas are cleared by burning or cutting mostly by tribal people. This type of cultivation is also called jhum cultivation or jhuming cultivation. The land is exposed to natural conditions of withering till plant or crop sowing. The cultivation is done for few years and then these tribal people move to another place for again clearing the forest area for next cultivation and so on. This practice may lead to formation of wastelands. Degraded pastures or grazing lands. These are the areas under permanent grasses where cattle or animals graze. These lands are initially degraded due to overgrazing by animals. Further, trampling of land by animals lose the upper soil layers which promotes soil erosion by water or wind. These lands should be used with care as these are fertile and good in texture. Mining or industrial wasteland. The land becomes barren to large extent due to excavations and movement of heavy machinery. This area is left exposed to natural withering process and it may lead to soil erosion due to wind and water. The remains of rocks and excavated waste material comes down with rains and wind to low-lying areas and get deposited there, creating more wastelands. Land or with or without scrub vegetation. Scrub vegetation is generally used for vegetation dominated by stunted trees or bushes and crown cover less than 10% of the area as can be seen in the picture. These plants are neither eaten by animals nor used by man. Scrub vegetation degrades soil quality. The barren land, which does not have any capability to grow vegetation, or the fallow land covered with grass, is called land without scrub. These lands are productive and can be used for agricultural purposes if managed properly. Degraded land under plantation crops. The plantation crops for commercial purposes. The monoculture agriculture lowers the soil fertility. The continuous monoculturing degrades the soil and the fertile land becomes a wasteland. Then subtypes of non-culturable wastelands. Number 1 are barren rocky area. Presence of big and small rocks hinder agricultural operations. Small rocks can be removed easily and the land can be used for raising crops. Where removal of big rocks is not possible, trees cannot be planted. Sandy area. These are found in desert, coastal areas, near riverbed and sea shores. Sand deposits may be found in a layer of 5 to 10 to 15 centimeter on the surface of soil, or the area can be totally sandy. High wind currents form sand dunes which hinders cultivation. Snow covered or glacial areas. These areas remains particularly under snow cover for whole of the year, usually found in moistures with slope which may be too much for correction. These are not suitable for agriculture. Causes of wasteland formation. The main causes of wasteland formation are: number 1, soil erosion due to high speed wind and water, salinization, alkalinization, inundation of land areas. Next, natural factors like tsunami, floods and tidal actions. Then anthropogenic activities like improper agricultural practices in terms of excessive uses of fertilizers, pesticides, monocropping, improper disposal of industrial waste, illegal and indiscriminate mining of minerals, zooming cultivation, climate change and environmental conditions like changing rainfall pattern, management constraints, etc. Then importance of wastelands or need for wasteland reclamation. It provides the source of income for rural people. Reclamation of wasteland will help in maintaining an ecological balance in area, maintains the local climatic conditions, ensures a constant supply of fuel, fodder and timber for local use. It improves the soil fertility. Wasteland reclamation. It is the process of turning barren, sterile land into fertile land suitable for agriculture or vegetation and cultivation. Reclamation means recovering physical structure of land to rebuild the ecosystem. These lands can be reclaimed mainly by 3 methods. Number 1, topography and soil management. Number 2, water management. Number 3, crop management. The soil management can be done with the following. Number 1, filling of gullies and leveling. This can be done by filling stones in gullies, followed by compacting after placing soil over it. The leveling of soil should be done to reduce the water erosion. Further, changing the course of water for small check dams are also useful for the purpose. Planting grasses and bushes along with water course also help to stop soil erosion. The next method is terracing. In this, the earth is shaped in the form of small leveled terraces to hold soil and water. The terraces are given inward slope to increase infiltration of water. The banks of terraces are made firm and compact by placing stones and planting grasses over these sides. Another method, scraping. This technique is used for soils covered with 2 to 3 centimeter thick layer of salts over it. This layer can be removed by scraping using spade. This is possible only at a small scale and may not be possible at large scale. Next, flushing. This method is used for lands where water soluble salts accumulate over land surface due to evaporation of water. To remove these salts, the area is first filled with water and allowed to remain there for few days. The water is checked for its conductivity so as to find that how much salts have dissolved. The water is then flushed off. Water should not be made to stand for long as salts can leach down to the subsoil. Then another method is deep plowing. Fallow lands, that is lands which are normally used for farming, but this is left with no crop for long time, become hard due to trampling by animals, settling of soil particles and lack of vegetation. To cover such lands, plowing should be done deep so that soil is open to absorb moisture from rain. Next method is drainage. Waterlogged soils are improved by this method. There are two types of drainage systems. One is subsurface drainage and other is underground drainage. Then addition of green manure and soil management. The method is used to reclaim the soils low in organic matter, nutrients and alkaline or acidic in nature. In this method, legume crops or nitrogen fixing plants are cropped on the land and plowed down in the soil when they are soft and without flowers. They fix atmospheric nitrogen and add organic matter to the soil. The chemicals like calcium carbonate, gypsum, fly ash and farmyard manure are added to the soil to increase the nutrient level, and lime is added to reduce the soil acidity. The next method is windbreaks. The method is used in areas having loose, dry, sandy soil and high intensity of speedy winds leading to movement of soil with wind. To reduce the soil erosion due to high speed wind, row of fast growing trees are planted on the boundaries of wasteland and banks of watercourse. These trees commonly used as windbreaks are popular, neem, shisham, bamboo and some fruits like bear, jamun, mango, etc. Silt trapping dams. When the water flowing from uplands cause soil erosion and siltation, to check the movement of eroded soil, big or small dams of reasonable height can be constructed against the course of water flow. Water is made to stand near these traps for a while and silt particles settle down, thus reducing soil erosion. Then another method is contour furrowing and bunding. This method is adopted for slopy wasteland. The contours or furrows are made to allow water to remain in contour or to move at a slow speed and hence reduce soil erosion by water. This increases infiltration of water leading to water conservation. Then another method is mulching. This method is used to conserve soil moisture during droughts and when there are no rains. Mulches of dry grasses, polythene, chemical mulch, etc. are used to cover the soil surface. Mulching also checks soil erosion and suppresses emergence of weeds. Water management. Water management consists of three options. Number one is addition of water irrigation. Number two, conservation of water or protection, and number three, removal of excess water or drainage. Number one, addition of water for irrigation. The addition of water to agriculture or vegetation is called irrigation. Mainly following techniques are used for irrigation. Number one, furrow or channel, used where the land is leveled and water is in plenty. Flooding water is allowed to flow over the field. It is used where water is in plenty. Then sprinkler, used where less but frequent water is required. It is very useful as no soil erosion, no loss of nutrients and water saving. Ring or basin method, it is used for irrigation of fruit and other trees. Individual tree is given a water at a time. No loss of nutrients, no soil erosion, but time consuming and laborious method. Another method is drip irrigation or trickle irrigation method. This is relatively modern irrigation technology. In this, water is made to trickle down near root zone. Trickling of water drops is slow, underground and continuous. There is no runoff water evaporation. There is no runoff water, evaporation loss, no leaching down of water. Conservation of soil moisture. It includes all the policies, strategies and activities to sustainably manage and conserve the soil moisture. It can be conserved by already discussed methods of terracing, mulching, wind barriers, silt trapping dams, etc. Some other methods used for the purpose are graded bunds. Graded bunds are simple earthen embankments constructed across the slope or contour of the area. When these are constructed at predetermined longitudinal grade, they are known as graded bunds. These are constructed where rainfall is more than 600 millimeter per year. The runoff from upper bund is retained in the lower bund, and again the surplus water passes on to the next bund, and in this way water is conserved in the soil. Then water storage in ditch. During rainy season, water is collected in ditches made at regular intervals depending on soil type and amount of water to be handled. The water stored in ditches can be used during water scarcity. Evaporation losses are overcome by covering the top of the ditches. Then drainage. This is the method of removal of excess of water from soil or subsoil. The most common method used is pumping out the water with mechanical methods. On slopy lands, channels are laid down and water flows down by gravity. Then the third method is crop management. Growing suitable crops and their management is another approach to reclaim wasteland. Those crops selected for wasteland should have characteristics like drought tolerant, minimum rate of transpiration, less nutrient requirement, etc. Growing legume crops and plowing them young in soil is a method. Multiple cropping, mixed cropping and crop rotation is done. Then another method is Enola and Jatropha plantations. The Enola commonly called Amla is a minor subtropical deciduous tree. It can withstand drought conditions and can grow in neglected regions due to its hardy nature. The fruit of the tree is in high demand due to its nutritional values. Similarly, another plant preferred to reclaim wasteland is Jatropha. It can grow on degraded soil and can assist drought conditions and can resist drought conditions. The seeds have high oil content which can be used for biodiesel production. Then another method is fuel wood plantations or wasteland reclamation. The land which cannot be used for agricultural purposes can be planted with fast growing species of trees having rotation cycle of 4 to 7 years. It can provide fuel, wood and fodder for cattle. Hence, it reduces excessive pressure on pasture lands. Then wasteland Indian scenario. India is a country having wide variation in geography, geology and climatology from north, south and east, west. India has only 2.4% of the world's geographical area, but sports over 16% of the world population. Further, India has only 0.5% of the world's grazing land, but sports 18% of the world's cattle population. This tremendous pressure on land due to ever increasing human and domesticated animal population has led to conversion of productive land into wastelands. Different agencies have made different assessments regarding wastelands in India. The difference is mainly due to use of different methodologies for estimation, changes with time period, use of different wasteland classification systems, etc. Some of the estimates are as follow. National Commission for Agriculture as per is 148 million hectares. NBSS LUP estimates projected in 1994 187 million hectares. Estimates in 2004 it is 147 million hectares. National Wasteland Development Board estimates it as 123 million hectares. Ministry of Rural Development NRSA as per 2000 reports 63.85 million hectares. Then the table 1 gives the waste classification scheme in India. In India, these have been classified in 7 to 8 categories. The category A include gullies or ravines land which have medium ravine or deep or very deep ravines. Then in B category comes the scrub land which include land with dense scrub and land with open scrub. Category C has waterlogged and marshy lands which include both permanent as well as seasonal. Then the D category includes land affected by salty or salinity or alkalinity. Both moderate and strong type of salinity and alkalinity are included in this. Then shifting cultivation category E has current zoom and abundant zoom. Category F includes scrub forest or underutilized notified forest land. It includes scrub dominated and agriculture land inside notified forest land, degraded pastures or grazing land and degraded land under plantation crops. Then category G, it includes sands, whether coastal, desert or ravine. Then category H, it includes mining, or industrial wastelands also includes barren rocky area and snow cover or glacial area. In order to accurately monitor the wastelands in India, Department of Land Resources, Government of India, in collaboration with NRSC, Department of Space, initiated a project titled National Wastelands Monitoring Project and has published document Wastelands Atlas of India 2010. In 2008, a harmonization exercise was taken up jointly by ICAR and NRSC, and a practical and management responsive estimate of wastelands or degraded lands was arrived at. The uniform classification has already been discussed in the previous table, that is table 1. Some of the facts of wasteland in India as per the Wastelands Atlas of India 2010 are: total geographical area of India is 329 million hectare. An estimated 47.22 million hectare have been found to be under wastelands in 2006, which is 14.91% of the total geographical area of the country. Jammu and Kashmir has more than 50% of its area under wastelands. Himachal Pradesh and Sikkim that have wastelands ranging between 40 to 50%. States like Uttarakhand, Rajasthan, Nagaland, Manipur and Mizoram have wastelands ranging between 20 to 40%. Meghalaya occupy only 15 to 20% wastelands. 9 states that accounted for the extent of wastelands ranging from 10 to 15%. 8 other states have wastelands ranging between 5 to 10%. 3 states and union territories have less than 5% area under wastelands. The Wasteland Atlas of India 2011 updated the data regarding wastelands in India in 2008-9 and compared it with the data of 2005-6 published in Wastelands Atlas of India 2010. The methodology and classification system used were similar to the same Wasteland Atlas of India 2010. Some of the important facts of Wasteland Atlas of India 2011 are: about 32,000 square kilometer of wasteland has undergone a positive change in entire country during the period by getting converted into non-wasteland. The declining trend was observed in 21 states of the country. Majority of the change areas have been found in the states of Rajasthan, Mizoram, Manipur, Gujarat, Bihar, Karnataka, Andhra Pradesh, Uttar Pradesh. Increase in total wasteland area was recorded in 8 states where non-wasteland has been observed to have changed into wasteland, bringing down the net decrease in wastelands during 2008-9 to 0.17% compared to 2005-6. The map 1 and 2 show the status of wasteland and change in wasteland status in 2008-9 compared to the 2005-6. Here we can see the map with different colors, and the legends of the different colors are shown on the right side, where we can see the in different states with different colors show the wasteland map of India 2008-9. Then map 2, Wasteland Atlas of India 2011 by Department of Land Resources, Ministry of Rural Development and National Remote Sensing Center, India Space Research Organization, Department of Space, Government of India is shown in this map 2. Here we can see 3 main colors: green color which is wasteland to non-wastelands, then dark brown color which shows wasteland to another wasteland, and then light brown color which shows non-wasteland to wasteland. Some data about the same has also been published by Ministry of Statistics and Program Implementation, Government of India, as Statistical Yearbook India 2007. Here we can see in the table the total land in 2010, in 2000, total geographical area in hectares and wasteland percent of the area in different states during the different years and as well as in percentage. Then next table shows the state or union territory total wasteland in different year in hectares, total geographical area in hectares and wasteland as percent of the area. Due to large number of anthropogenic and natural activities, the land degradation has increased. In order to support the ever increasing population of humans and domesticated animals, there is utmost need to reclaim the wastelands. Programs are being run by different countries to reclaim the wasteland, and some of these has shown positive results. The mapping of wastelands after regular interval is necessary to keep an eye on their status.